Hello Space Cats and welcome back to my channel. In this week's video we're going to be talking about 3D printing in space. A 3D printer deposits thin layers of material on top of each other to create a 3D object. This material is typically molten plastic that is cooled or cured via UV light, before the next layer is then added. 3D printing is already used widely in car manufacturing, building houses, and even medicine, with applications such as working human organs. But 3D printing in space is an entirely different ballgame. Regular 3D printing relies on gravity to hold each layer together before they cool and dry. Obviously, we can't do that in space, but a simple solution would be to use a sticky substance in between each layer. This can be challenging as well because we don't want it to stick everywhere, and we need to make sure that it doesn't damage the base plate. Accuracy is another big challenge and really important in space. In 3D printing, the surfaces are often imperfect, which would be prone to cracks, but even the slightest error could have catastrophic consequences in space. Once gravity is accounted for, another difference to Earth 3D printers is the environment. The ISS is a closed environment, and recent studies have shown that commercial 3D printers generate heat and ultrafine particles that can lead to cardiorespiratory problems and even stroke in unventilated environments. This is a particular concern in 3D printers that print metals because typically they use powdered metals deposited on a base plate before a laser is used to heat and weld and melt the powder. These types of printers are typically very large, have large energy consumptions, and are not ideal for space since the powders are combustible and a respiration hazard. But some parts in space need to be made from metal. Furthermore, extreme temperature changes and meteors are also big concerns for 3D printing in space. But contrary to what you might expect, microgravity has been found not to affect the properties such as the density of the 3D printed product. Currently on the International Space Station, NASA sends up about 3,000 kilograms of spare parts every year. However, these resupply missions occur only every few months, and even then the cost of transporting things into space is not cheap, about $50,000 per kilogram. This means that if a simple component is faulty and needs to be replaced, it may take a very long time before it gets there. Current 3D printing takes a few minutes to a few hours, and so can drastically reduce the time to obtain parts and can be more reliable and cheap. The huge cost tied to transporting raw materials into space is prohibitive and means that the future of extraterrestrial construction rests on the development of technologies that are able to employ in situ materials. Research is already underway for the use of lunar or even Martian regolith as source material for 3D printers on the Moon and Mars that can be used to 3D print future homes. If humans want to get to Mars, then 3D printing in space capabilities must be met. Otherwise, they would have to bring everything with them plus spares. With 3D printing, we can make rather than take, which could be life-saving. Made in Space launched the first 3D printer in space on the 21st of September 2014. The 3D printer was operating on the International Space Station, where astronaut Yvonne Kagel demonstrated it by printing a buckle for part of some exercise equipment. Other prints demonstrated with the zero-G technology include a wrench, an antenna, a part for the oxygen generation system, and many, many more. The same company also manufactured a valuable optical fiber, ZB-LAN, aboard the ISS. This type of optical fiber is far superior to the silica-based ones. However, it's much harder to produce on Earth due to gravity. and this is kickstarting off-Earth manufacturing. Thank you so much for watching this week's video. Let me know in the comment section below what you want me to talk about next, and in the meanwhile, if you enjoyed the video, please don't forget to leave me a like, share and subscribe.